Hello everyone, Assalamu alaikum. My name is Adnan Shakib and I like to represent a voting system using a full adder and a parallel binary adder. And our fellow group member Jyotimoy Sarkar Shubho, Abdullah Al Noman Talukdar and Majidul Islam Saki. Let me introduce the system. A voting system usually full adder and a parallel binary adder used for determined option and voting for issues. Simulation grouped number for yes and no votes can be applied in groups settings. The main goal of this project is to build a voting system utilize full adder and parallel binary adder for real-time determination of yes and no votes within an assembly. The system architecture involves switch representing yes or no option at each other assembly option and displayed to indicate the respective vote counts. Yes, a diagram is represented for six setup cycle to admitted longer assembly through additional models and parallel adder and display circuit. The overview. An example of a full adder and a parallel adder application is a simple voting system that can be used to simulation provide the number of yes votes and the number of no votes. This type of system can be used where a group people of assembly that there is a need of immediately determination option for or against making decision or voting for certain issues or other.
Everyone, today I am excited to introduce to you the apparatus we will be using for our voting system demonstration. Our setup includes essential components such as 5-volt power source to provide the necessary electricity, connecting wires to establish connection between different elements, resistor to manage current flow, LED for visual feedback, and crucial integrated circuit, especially IC7483 and IC7447. Additionally, we have common anode 7-segment display which will serve a visual output for our voting system. Together, these components form the backbone of our innovative approach to voting system. Now I am thrilled to shed some light on the role of IC7483 in our voting system. This integrated circuit is a key player in our setup as it serves a full adder, a fundamental building block in digital automatic circuit. With its ability to perform addition operation on binary numbers, IC7483 plays a crucial role in trailing votes and calculating totals. Its effective design and reliable performance makes it indispensable compared to other voting systems, ensuring accurate and swift computation and voting results. As we explore further, we will see firsthand how. After that, I am excited to discuss to you about the specific configuration of IC7447 in our voting system. This integrated circuit is a specialized component known as BCD to a 7-segment decoder or driver. What that does mean for our voting system? Well, IC7447 is responsible for converting binary code decimal output for arithmetic operation into signal that can be displayed on our anode 7-segment display. In simple terms, it translates the numerical data in a formal format that is easily readable and interpretable by users. Without IC7447, our voting system would lack the vital link between computation and visual representation. Another vital component is the common anode 7-segment display. This display technology is widely used for its simplicity and effectiveness in conveying numerical information. Each segment of the display can be individually activated, represent different numerical digits, making it ideal for showcasing voting results and other numerical data. With this clear and conscious presentation, the common anode 7-segment display provides user with the instant visual feedback, ensuring transparency, accessibility in our voting process. Let's explore how the display exchanges our expressions and functionality seamlessly. Now we will see our simulation, multi-sim simulation, and now we'll see our multi-sim simulation. Now I like to show you our simulation. This is our simulation. As you can see, there are 3 7483 IC and 1 7447 IC, and in that 7447 IC there is a 7-segment display attached. We used 6 switches to represent 6 boards. If the switch is on, one switch is on, it will count as 1 port. You can see from the simulation that 3 switches are on, so the 7-segment display shows 3 volts. Now if we continue to the next slide, there are 5 switches are connected. Now it shows the 7-segment display shows 5.
My name is Mujahidul Islam Saki. In this section, I describe about hardware implementation. Our voting system employs digital logic circuits including full adder, parallel binary adders, and display circuits to enable real-time determination of yes/no votes within an assemblies. Here we use some components, switch which is represent yes/no options. Then we use digital displays. We use common anode 7-segment, integrate circuit. We use IC 73 and IC 83 and IC 73. IC 73 is a 4-bit binary full adder, and IC 47 for translate this result into the display. Then we power source use 9-volt DC power, and also we use connection wires resistance. And first we set up all switches are connected to the input pins of the system by connection wires. These switches are configured to ensure accurate input reception. Then binary inputs from all positions are fed into the IC83, which is performed binary addition. The output of adder represent the total count of yes/no vote in binary form. Then the binary output after that from the adder are decoded and converted into signal to 7-segment display using IC47. The display shows total count decimal format. Here is my presentation.
Assalamu alaikum, and thank my previous presenter to give me opportunity to present my slide. Firstly, advantage. First of all, this voting machine first advantage is fast and accurate vote counting, simple and efficient design, and scalable for large group and community. And the next slide is limitations. There are some limitations of this project. Firstly, binary voting format. There are only 2 options. Release on hardware setup and may not be suitable format remote voting system, and then need power supply. Then go to the next slide is conclusion, and the next slide is conclusion. Overall view is this project is and the voting system using full adder and parallel binary address present a simple efficient solution. This simple efficient solution and quick voting continue in small and medium size group. However, its limitations, particularly regarding voting opportunity and accessibility, should be carefully considered of specific applications. Now, thank you all. Thank you, sir, and thank you.